Hello dear students, this is Dr. Aisha Nazuk here, and today we are going to start with the first lecture of introductory course on econometrics. Those of you who are watching the first video on my channel, which is Rao Hub, before I start the lecture contents of today's discussion, let me inform you all the viewers that I have different type of playlist on my channel. So I do have a playlist that focuses just on the introductory concepts of statistics. Then I have a playlist that focuses on applied econometrics, and I'll make a playlist on introductory econometrics as well. And there are some other playlists which, if you have time, you can explore. They are not related to statistics or mathematics, rather they are something different. For example, I have videos on positivity and human behavior. I have videos on the genre of comedy. So this as it's rightly said, that this world is interdisciplinary. The contemporary era is all about interdisciplinary paradigms. So the channel Rao Hub is sort of a place where you can see multiple type of information. But don't worry, I have very coordinated and synchronized playlist for each courses. So for the students of NAST who are currently enrolled in the course Introduction to Econometrics, I have the playlist labeled exactly with this title, that is Introduction to Econometrics. Okay, so this was all about the introduction of the channel and in general about the video. So today the lecture is all about a very basic and introductory lecture. It starts with what is econometrics. First of all, I would like to mention that some of the students of economics, they are sometimes confused that why do we need statistics, why do we need mathematics, why do we need to study econometrics, right? Although I expect that most of the students who are in their senior semesters, by now they have the acumen enough to appreciate the contributions of mathematics, statistics, econometrics, and in general all the quantitative domains. But let me emphasize once again that econometrics is nothing but a science of testing economic theories, right? As you can see here on my screen as well, that it's just a science of testing economic theories, right? For example, by now you must have studied different economic theories that we will discuss in the coming slides, some of them in the coming slides as well. So, for example, an economist comes up with a good theory of explaining the relationship between, let's say, interest rate and savings. And you want to empirically test whether the relationship proposed by that economist, does that hold in practice or not. So what you're going to do, you're going to take observations or random samples to inquire whether the relationship that is being proposed by the economist, is that correct or not, or is that a fair approximation or not. So this is a very basic and quick definition of econometrics. Next we see that it's a set of tools used for forecasting future values of economic variable. For example, if you want to forecast what are going to be the sales value of a firm, right? So you're operating a firm and you want to predict that what are going to be the sale patterns in the coming quarters. So you can use econometric methods. For example, if I want to see country level policy, then I can predict what will be the growth rate of an economy. And of course, right now I'm giving very basic and surface level examples. We will dig deeper in these examples in the later part of the course. Okay, so one more explanation. Econometrics is the process of fitting mathematical economic models to real world data, right? This example that I just mentioned, that an economist proposed the relationship between interest rate and wages. So you see, what we will do, we will try to use some or make some mathematical economical models, in other words some equations that can, you know, mathematically express the relationship whatever was being proposed by the economists between the two random variables, right? So using these different type of and basic definitions, by now it must be clear to you that econometrics is actually is actually applied on historical data to make policy recommendation, right? For example, as we discussed about the firms, so if we want to predict the sales of a firm, and let's say sales of a firm depend upon many factors, but let's say if we say that the sales depend upon the price, right, the price of the product that you are selling, so what price should we set so as to maximize the sale? So these type of policy decisions, they falls in the domain of econometrics, right? Okay, so who is an econometrician? For example, if I use the word mathematician, it's very clear in your mind that that person is expert in mathematics. If I use the word statistician, you'll say that it implies that that person is expert in statistics. Now what if I use the word econometrician? Or if by virtue of the contemporary phrase, if I use who is a data scientist? These two actually are, I won't say same, but pretty much some things that converge. I mean, if a person is a good econometrician, he can easily become a good data scientist. So, but the point is, who is an econometrician? Okay, so econometrician is a person who tries to find the assumption that are both sufficiently specific and sufficiently realistic to allow that person to take the best possible advantage of the data available. Okay, let's simplify these things. Actually, who is an econometrician is a person, let me express in very simple words. Econometrician is a person who actually tries to examine the underlying data generating pattern. Now don't be confused by this seemingly technical phrase, data generating pattern. It's nothing technical. You see, things are random. For example, we have different random variables, we have price, we have growth rate. So what is the pattern, or are there any fixed sort of, you can say, methods in which those values are being generated? For example, if I talk about price, and let's say I look at the price value of a firm for the last 30 quarters. So now I want to explore that, is there any mathematical equation or a statistical equation that could be used as an approximation of this data on price? That is, I switch in different values of some random variables and I'm able to generate the values of prices set by that firm. So econometrician is a person who is trying to make a model that can approximate reality, right? So this is what is written in these words, that it checks the congruence of the economic theory with the pattern depicted by the actual data. For example, if economic theories say that there is a particular type of relationship between price of a product and quantity demanded of a product, right? So law of demand says that there should be inverse relationship. So now if we have actual data on price and quantity demanded, we can easily check whether that pattern is in congruence with the economic theory of law of demand, right? So this is the job of econometrician. Okay, so we have two types of basic types of econometrics: econometric theory and applied econometrics. It's very simple that econometric theory is basically concerned with developing new type of mathematical approaches to propose different models, right? In simple words, if I am trying to propose a new formula, right, to explain, let's say, some economic theory, that is econometric theory, right? In simple word, I am proposing a new formula to explain an existing economic theory. So that falls in the domain of econometric theory. Next we have applied econometrics, which most of the social scientists, they study and use more of this discipline as compared to the econometric theory, because the econometric theory part is covered by someone who is ideally an expert in mathematics. So that's why he can, explore and analyze different types of formula. But social scientists, such as an economist, generally, especially at an undergrad level, they study applied econometrics, which is, instead of proposing new formulas, we see the application of existing formulas to explain different economic theories, right? So the distinction is econometric theory is a mathematical pursuit, whereas applied econometric is an applied pursuit, right? Okay, next I introduce a new concept, and why am I suddenly switching to this is basically, in this course you're going to explore different dimensions of statistics and mathematical inquiries. So to understand and to appreciate that part of the course, this is sort of a technical backstopping that I am giving you. Okay, so what is Bayesian logic? Okay, so most of you, I assume that you know what is statistics, right? Because if I'm addressing my current students enrolled in NUST in BS Economics program, you've had courses on statistics, you have had courses on probability theory as well, and you've had courses on mathematics. So it's quite clear that this audience is pretty much clear what is statistics. To rest of the audience who are by now not clear what statistics is, then it's highly advisable that before starting this playlist of econometrics, you go back to the other playlist which focus on introduction to statistics, and then start this playlist. Okay, so what is Bayesian logic or Bayesian statistics? It is actually nothing but making use of current data or recent data to update your estimates of probabilities, right? Let me explain through one example, then it will be more clear. Okay, so in these slides, the good part is that you see two Pakistani athletes, Rabia Ashik and Rubab Raza. So let's say we have data on 4 marathons between Rabia Ashik and Rubab Raza. So let's say out of those 4 marathons, Rabia won 3 times while Rubab managed only 1. Right? Rabia won 3 times. So let's say if to the general audience I say that if you were to bet on the winner of the next race, who would she be? Pardon the typo, it should be she, not he. Okay. So as you can see, based on the data displayed here on the screen, most of you would say that since Rabia has won 3 times, so you're going to bet that Rabia will win the next race as well, right? But let me offer a twist in this example, which will introduce or make clear the Bayesian logic. Okay, so continuing the same example, let's say I provide you some additional information. You see, we have fresh data. As I said, Bayesian logic uses fresh data to update your estimates of probabilities. So what's the fresh data? Let's say you have an additional piece of information that it rained once when Rubab won and once when Rabia won, right? And it is definite that it will rain on the next date as well, right? So we are putting some you can say qualifications here, or we are imposing some restrictions here, that both the player have won only once when it was raining, and now it's confirmed that it will rain on the next date. Now who would you bet your money on, right? So what has happened? Now you can easily see that the chances of winning for Rubab have increased, right? How? You can simply compare the data here. Rubab once 3. Rabia won 3 times and Rubab won only once. But now what's next here? What's new here? It rained once when Rubab won and once when Rabia won, right? So now you can see that the chances of winning of Rubab have increased, right? So prior information has helped us in evaluating the posterior probability of winning. So don't get confused by this term posterior probability. It is something just updated probability based on the updated information that you have got. So this is Bayesian logic, right? Okay. Now coming to different or the branches of econometrics, which to some extent I have already told you that we have theoretical econometrics, which is a mathematical pursuit, and applied econometrics, which is more of a pursuit or an inquiry taken by social scientists. Both of these type of econometrics have a classical approach and a Bayesian approach, right? Both of these. So what is classical approach? It is the same approach that you have been studying in statistics so far. It doesn't incorporate any fresh information, and it doesn't update those next probability, whereas the Bayesian logic incorporates fresh data to present estimates of updated probabilities or posterior probabilities. By the way, this course is concerned only with the classical part of applied econometrics, right? So the Bayesian econometrics, that will be covered later, not in this course. Okay. So next we present a particular you can say sequence of steps that is generally followed whenever we take up an econometric inquiry. So the very first step is you have to state the theory or the hypothesis that you are testing, right? For example, you have to, if you want to analyze the relationship between price and quantity demanded, then you must express your hypothesis, or you, for example, you will write that there exists an inverse relationship between the price and quantity demanded. So that is the very first step. The second step is that you have to choose a suitable mathematical model, or you can say you have to choose a specific equation that could be used to express the relationship stated in step 1. Next is you make that mathematical model into a statistical model. So what is the difference? Although we will cover later as well, but here I can just say that a mathematical model is fully deterministic. There is nothing random in it, right? Whereas a statistical model, it has some randomness in it. A very stereotypical or well quoted example is if you take the square of a plus b whole square is always equal to a square plus b square plus 2 times a into b. So that is a mathematical equation. But statistical equation has something random in it. For example, if we are given price of a product, then we can predict the quantity demanded, but we cannot give the exact value, right? There are some random factors, you can say that other factors that may influence quantity demanded. So we will later learn in the course how we incorporate those random factors in the model. Okay, so the fourth step is we obtain data. For example, if I relate with the price and quantity demanded example, then I will take random data on price of the product and quantity demanded of that product, so that I can estimate the parameters of econometric model or the statistical model. So how are we going to estimate? For now I keep it for the later part of the course. I am not going to discuss the typical or the in detail estimation techniques, but for now you can just have an idea that after obtaining the data, we apply some techniques and we estimate the parameters of the econometric model. And then we do some statistical hypothesis testing, and then we forecast. For example, we are going to forecast the values of quantity demanded for a given value of price. And then we use the model for control or policy purposes. So this was a basic skeleton of a typical econometric inquiry that we are going to further elucidate with the help of another example. Okay, so let's say if we start with the first step of a typical econometric pursuit, the first step is statement of theory or hypothesis. So let's say the celebrated economist Keynes stated that the marginal propensity to consume, or the MPC, is greater than 0 but less than 1, right? That MPC is always positive, but the upper bound is 1. So let's say I want to test this theory, right? So I need data on consumption and I need data on income. So before that, I express my mathematical model that consumption is equal to beta 1 plus beta 2 times income, where beta 1 and beta 2 are the parameters, right? We will discuss these in more details in the upcoming videos. So for now we just say that these are parameters. So you can see that there is nothing random in this expression. This expression says that if you have a value of income, you can easily calculate the value of consumption, which is unlike the practical scenario. I mean, it's not confirmed that if you have income level, let's say 100, and the beta 1 and beta 2 are known, then you cannot calculate, or you should not calculate, but you can estimate the value of consumption. So now comes the statistical model. You see, the statistical model says same as the mathematical model, but we have this random error part. So what does this random error says? That consumption, even if you have a given value of income and estimated values of beta 1 and beta 2, if you put all these values in the expression, even then you won't have the exact value of consumption. You will have a estimated or a predicted value of consumption. So this is the specification of the statistical or the econometric model. So coming here, this was all about the idea of marginal propensity to consume. I assume that most of the people watching this video are well versed with this concept, but let me give you a very brief explanation for this as well. You see, what is the change in consumption due to change in income, right? If income changes by 1 unit, then consumption changes by beta 2 units, and this part is beta 1 or the intercept. So this beta 1, as you saw here in the expression, beta 1, this is the intercept, where this beta 2 is MPC or the slope, right? This slope beta 2. Okay, so what happens if we take actual values of consumption and we have actual values of income, right? So remember that what we are treating here, that if for a given value of income we can predict consumption. See, if this is the, for example, income level, right? So according to our prediction, at this income level, this should be the consumption, right? Exact this, the straight line. But you see the dotted lines, or so the dots are somewhere else. These are actually actual pairs of consumption versus a given value of income. So why the difference? Of course, no prediction can be 100% accurate. So if this is the actual consumption and you are predicting this, then this difference is residual or the random error part, which here I have represented by epsilon or u. So these are different terminologies in different textbooks. Sometimes random error is expressed by u, and sometime by this symbol epsilon. Okay, so next is we have to obtain data or collect data on income and consumption. So consumption is per capita expenditure and income is GDP or the gross domestic product. So we have to take actual data, right, so that we can see that MPC should be greater than 0. What does that mean? That the slope will be positive, right? Remember, we said that this beta 2 is marginal propensity to consume. So according to the Keynesian logic, this should be positive. So that is why even before collecting the data, we have a prior expectation that if I plot the values of consumption or per capita expenditure against income or the GDP, that line will be upward sloping because MPC is positive. Okay, the next step is to estimate the econometric model. So for now, I am not discussing how these estimates are derived. We'll come to it in the later part of the course. For now, I say, let's say that the equation that I develop is consumption, or actually I should have applied a hat here because this is predicted consumption. As I said, you can never calculate consumption, you can predict. So this form hat, C hat, is correct. So predicted consumption is equal to beta 1, which in this case came out to be minus 184.08, plus beta 2, which is marginal propensity to consume. You can see it is positive and it is less than 1. So you see that the Keynesian logic this data seems to be in in agreement with the Keynesian logic, because the marginal propensity to consume is less than 1 and it is positive, right? Next, I can do the hypothesis testing part. We will come to it on later, because right now I haven't provided the p-values, which you will acquaint yourself soon in the upcoming videos. So for now, let's ignore the hypothesis testing part. So the next step is forecasting, right? Let's say if I have GDP or income of 1997 and this value is, let's say, this, so I can switch in this value, the GDP value in the above expression, to get estimated consumption or per capita expenditure in the year 1997. So if let's say that year ends and I get the actual consumption value. So the estimated value and the actual values, they are different, right? As I said that no model can predict with 100% accuracy. So the difference between actual and estimated consumption is due to the random error or the residual part, which in this case is 37.82. Okay, so next we discuss that we know that there are different type of theories that exist to explain the relationship between the same pair of random variables. For example, Friedman developed a model of consumption called the permanent income hypothesis, whereas Robert Hall presented the life cycle hypothesis. So these are two different theories, but the relationship that is being analyzed is between consumption and income. So same pair of random variables, but they could be put under the Friedman theory or under the Robert Hall theory. So for example, if you have data on consumption and you have data on income as well, so you can see whether the Friedman hypothesis is a better suited one or the Robert Hall one, right? Those of you who are not aware of the Friedman hypothesis or the permanent income hypothesis, it simply says that people will spend money at a level consistent with their expected long-term average income, right? That whatever a person is expecting that he will earn in the long term, on average, his consumption will be in accordance to that expectation. Whereas the life cycle hypothesis says that a person seeks to smooth consumption throughout their lifetime, right? If at a given moment in time, if my income is low, I'm going to borrow, right? And if my income in a given period is high, then I'm going to save. So these two type of theories exist to explain the relationship between consumption and income. For now, I'm not going to go into the details of what type of data will be conducted and how we're going to decide which theory is the best suited to the data that we are given with. Why am I discussing it here now is because that it is fairly possible that if you are given different random variables, then you have more than one theory that can be checked whether theory 1 seems a good fit for this data, or theory 2, or if you have another one, theory 3, right? So this is a typical econometric pursuit, that you are given, different type of theories and you want to see which is best suited to the data that is given to you. Okay, so I won't repeat because this is somewhat already covered in detail. Okay, so how to choose between competing models or competing theories, right? We will learn in the later part of the course. For now, what you need to understand is there must be some criterion, some objective criterion on the basis of which you can say that this model seems to be a better fit, or this theory seems to be a better fit as compared to the other theory. So we will learn later in the course that we need to have a certain criterion that can help us understand or decide that which model is better, right? For now you can understand that if I talk about the consumption and income, then the model which predicts consumption more closely or more accurately, that is going to be a well suited model. But these things are not as simple. We will cover in detail later on what are the criterion for model comparison. Okay, so now start what is meant by the term regression. It was first introduced by Sir Francis Galton. What Galton found at that time, the interpretation of regression was that a data has a tendency to converge towards the average. So what Galton actually took, he took data of the heights of parents and heights of their children, and he saw that the tall parents, they have tall children but not as tall as their parents, right? Similarly, the short parents have short children but not as short as their parents. So in other words, the heights are converging or regressing towards the average height of a population, right? For example, the heights are converging toward the average height of a Pakistani male. So that was where the term regression started from. Now I'll say before I come or switch to the contemporary interpretation of regression. As I said, Francis Galton and Carl Pearson, they both reported that by making use of the height data, they both reported that the heights have a tendency to converge toward the average height of the population. So they call this as regression to mediocrity, right? Now coming to the modern interpretation of regression, it is simply dependence of one variable on one or more other variables, right? So this is the modern interpretation. So we will explain this further in the coming slide. So let's say we have, if I explain this whole scenario of height in contemporary or modern day interpretation. So if we have height of father equal to 60, so what is the expected height of the son? So this, encircled point, this is the expected height or the average height of a son whose father has a height of 60. That is, you can see, let me put it another way, that a father whose height is 60, there may be one son whose height is this cross, whereas another father whose height is also 60, but his son is, let's say, at this level, cross level, right? So what is it saying? That even if the height of the father is same, but we can have height of the son having different, right? That is, these are actually father having height 60 and son having height a bit less than 60. Then another father whose height is also 60, but his son is, let's say, 65. So on average, if I say, this encircled part says that on average the height of a son whose father is has height 60 is expected to be this much, which is like somewhere around 62 if I extend a line here, roughly. So this is the modern interpretation of regression, right? That's why you saw this term here, expected value of yi given xi. In other words, the average, expected value is same as average. So expected value of son's height for a given father's height. So that is what we are going to estimate. So this is the modern interpretation of regression. Okay. So this part I think I have already covered, that what are deterministic relationship and what are statistical relationship. Simply a statistical relationship has something random in it, whereas a deterministic relationship has no random part in it, right? Okay. So since this course is predominantly focused with the idea of regression, so let's start the building concepts of regression. So keep one thing in mind, that what we introduce regression as dependence of one variable on the other variable, or if I come back here, dependence of one variable on one or more other variables, right? But that dependence cannot be stated as causation or cause. Let me explain with the help of an example. Sometimes what happens, that whatever relationship is like seemingly strong, it is due to lack of information. How? For example, let's say that there is a significant relationship between ice cream sales and homicide. I repeat that if you have data on ice cream sales and data on homicide, right, you don't have data on the rest of the parts given in this diagram. Let's say you have data on ice cream sales, data on homicide, or at least you don't have the conceptual clarity how ice cream sales and homicide are correlated. But let's say that your data says that there is a strong positive correlation between ice cream sales and homicide. So if you regress, let's say ice cream sales on homicide, that is, you take the ice cream sale as a dependent variable and homicide as an independent variable, it is fairly possible that your beta will come out to be highly significant. Although on the surface of it you will say that what homicide and ice cream sales have to do with each other. It's because we are not using full information, right? As we said, that the sometimes relationship between random variable is more due to the lack of information. So let's say if we analyze, and if we broaden our perspective, and we see that actually why ice cream sale and homicide are positively correlated is because there is a cause. The actual cause is sunny days, right? Even if the ice cream sales and homicide were according to the regression strongly related, you're not going to say that ice cream sales is a cause of homicide or homicide is the cause of ice cream sales. The cause may be something different. For example, the actual cause is sunny days, because sunny days cause an increase in ice cream sales, and sunny days may increase the probability of going out, and if that area is marked with increased crime, then increased probability of homicide, right? So regression does not imply causation. Causation inquiry is something different. Okay, another example to explain the idea of causation. Let's say the Human Development Index of Pakistan, and if let's say I regress the Human Development Index of Pakistan as a function of Human Development Index of Bangladesh, right? So, and I find that the slope is positive and it's significant as well. Does that mean that if I improve the HDI of Bangladesh, it's going to improve the HDI of Pakistan as well? In other words, is there any causal relationship? Of course, the answer will be no, right? Even if the slope is positive and both HDIs are positively correlated, it may be due to some other factor. Maybe it is due to a region specific improvement in HDI or a region specific poverty alleviation scheme that is improving the human development index in both the countries. So, regression does not imply causation. So next we talk about the difference between regression and correlation. So the correlation coefficient only measures the strength of relationship, whereas the regression will not only measure the strength, it will also give me a an equation that will relate the two variables, right? In other words, in regression we try to estimate or predict the average value of one variable based on the fixed values of the other variables. So an additional difference is, in correlation nothing is dependent or independent. We are not concerned which variable depends upon the other. Whereas in regression we are pretty much clear on it that which variable is dependent and which is independent, right? So generally the random variable is assumed to be the dependent variable is assumed to be random, whereas the independent variable or the explanatory variable are assumed to have predetermined fixed values, right? Okay, so then these are some terminology and notation that you can, I won't read all of these because they are quite evident on the screen, but why am I providing you this information is because if you refer to different textbook or different research papers, these type of expressions may be used. For example, the dependent variable may be called the controlled variable or the endogenous variable, and so on. There are different terminologies that could be used, and it is expected that you know all these terminologies, right? Okay, so let's discuss a practical application or a practical example of regression that will further clarify how we are going to fix the values or a predetermined fixed values of a random variable. Let's say a monopolist can fix price or output, but not both, right? So a monopolist can fix price or output, and he may want to find out the response of the demand of a product to changes in price. That is, a monopolist is trying to analyze, actually the sole purpose of a monopolist is to maximize profit, and he has significant control on the prices as well. So he can simply analyze which price level is best suited to maximize the demand, right? So this type of an experiment will help you to understand the price elasticity. What is price elasticity? Simple price responsiveness, right? That is, if price changes by 1 unit, what will be the change in the demand? So this is one application of regression. Okay, so next we are going to discuss the standard notations or the conventional notation that are used to express different type of data. We are also going to discuss what is a cross-sectional data and what is a time series data. For now, let's understand that the subscript I is used for variation in cross-section, whereas the subscript T is used for variation in time. So let's understand these in further detail. So a time series data, as the name expresses, it is a set of observation taken on different time periods. For example, we can have data on, let's say, daily stock prices or daily weather reports. We can have weekly money supply figures, or we can have monthly unemployment rate, and so on. So the simple thing is that in time series data, the time is varying, right? Time varies in time series data. So what are different issues in time series data that we will cover in a later lecture as well? The idea of non-stationarity, but just to give you a very basic idea of non-stationarity is, if you see these time series values, let's say they are plotted here on a scatter plot, you can see that this data, the average value seems to change in different intervals. For example, if I use this yellow line, this average is different than the average in the next time period, let's say this red line, and so on. So in very simple words, that if the average and the variance of a series changes over time or over different intervals, then that series is non-stationary. So this non-stationarity issue is generally more pronounced or more significant in time series data. That is why the conventional econometric approach is not valid for time series data, but we will come to it later on. Next we have cross-sectional data. Cross-sectional data are data on one or more variables collected at the same point. For example, we can have wheat prices in various cities of Pakistan for year 2016. So time period is fixed and cities are varying. That is, we have different cities. That is why this is a cross-sectional data. So what are the, you can say, problems of cross-sectional data? Let's say we have another cross-sectional data here. In this case we have two random variables. Y is the hourly wages of a person and X is the daily amount that person gives in charity. So if these are the hourly wages 100, then the charity is 23. If the hourly wage is 90, then the charity is 12, and so on. So what is the issue in cross-sectional data is that the variation patterns are different. That is, for example, if I look at only this Y values here, you can see these yellow line, the data values in these yellow highlighted part, they are quite different from the data values in this blue or turquoise highlighted part. So you can say that the variation pattern is different. These values vary a lot, whereas these values vary less. So in technical terminology, we can say that this is an issue of heterogeneity. Let me explain with another simple example which will, I hope, make it more clear. Let's say we have data on marks of a single student in mathematics for 4 consecutive semesters, right? Data on marks of a single student. This is scenario A. Now scenario B is you have data on marks in mathematics for 4 different students in the first semester. Now you should be able to identify that the first data is time series data because the semester is varying, whereas the second data is cross-sectional data because the cross-section or the students are varying, time is constant, first semester, right? So out of these two scenarios, where do you expect more variation? marks of a single student in different semester, are they going to vary more, or marks of 4 different students in a given semester? So it's very easily you can easily envisage that scenario B. You will have more variation here, because this is a cross-sectional data. So pardon that there is a typo here, that this former case is written, ignore the last line, right? I repeat, ignore the last line, just focus here that the expected variation will be higher in this scenario, second scenario, because this is a cross-sectional data. So in cross-sectional data, expected variations are higher, and this is what we call the problem of heterogeneity. Next we have pooled data. So pooled data is a mix of time series and cross-sectional data. For example, we have 3 countries, country A, country B and country C, and we have their per capita income, we have their human development index and trade openness index, right? So in the pooled data we have 3 countries, country A, country B and country C, and we have 3 random variables, and the time period is also varying, right? Even if I don't have this second and third column, even then this will be a pooled data. Why pooled data? 3 countries and different time periods. It is not necessary that if we have 3 countries then we should have 3 years as well. That is just by chance here purely. So even if I have this first and second column only, this part only, even then that will be a pooled data. That is, for country A we have per capita income for the year 2000, we have per capita income for the year 2001 and so on. So the cross sections are also varying, that is the countries, and the years are also varying, that is 2000, 2001 and so on. So we can have either this part as a pooled data, or this entire table is also pooled data, because we have different cross sections and time periods are varying. So we can have one random variable, for example only per capita income, or we can have more than one random variable, that is, for example, per capita income, human development index and trade openness index. So this is pooled data, which is a mix of time series and cross sectional data. So next we have 2 related data set, pooled data and panel data. We just said that pooled data is where the cross sections are varying as well as the time period is also varying. So same is the case with panel data as well, right? Even in panel data, time varies as well as cross section. So what is you can say common in pooled and panel data is, in both of these data sets both time varies and cross section varies. Then what is the difference? The difference is, in pooled data the cross sections are independent. For example, country A, country B, country C, these are independent observations, so that is a pooled data. But in panel data the cross sections are, you can say, dependent, or in other words the sample does not changes. Let's say that there is a survey that is asked with, let's say, same set of respondents, let's say 100 respondents for the next 3 years. That is, for example, in year 2000 100 respondents fill a questionnaire. Then in year 2001 the same respondents, the same 100 respondents fill the other questionnaire and so on. So if the sample does not changes, then it's a panel data. But if the sample changes, then it's a pooled data, right? So next, these are, I'm not going to read these. Actually, in the context of Pakistan, these are different type of data sources or publications that you can use to curate data on key economic variables. Next, we have experimental data and non-experimental data. As the name suggests, experimental data is sort of a controlled data generated in a controlled environment, whereas non-experimental data is a data generated in an environment that is not fully controllable. For instance, if you are assessing the impact of obesity on blood pressure, then you would want to collect data while keeping other things constant: eating, smoking, and drinking. So what has this to do with experimental and non-experimental debate? It's just that generally in social sciences the data is non-experimental. In other words, it is not sort of a lab environment. Things are random in practical scenarios. So for example, the blood pressure will be a random variable. But what we are going to say, we are going to assume or put some you can say constraints on the model, that we will say that this is the impact of obesity on blood pressure, while we are assuming, or we are saying that other things remaining constant, that is the eating, smoking and drinking habits, they remain similar, then we can predict the relationship between obesity and blood pressure. So that is a typical social science scenario which is non-experimental, right? Experimental data maybe, that is more in natural sciences. For example, you conduct an experiment in the lab and you can control temperature, you can control different settings, and then you analyze the outcome of that experiment. So as we said that in social sciences the data are generally non-experimental in nature, that the things are not directly under the control of the researcher or the investigator, right? Okay. So next we're going to discuss balanced panel versus unbalanced panel. Actually, this should have been covered right where I discussed the panel data, but pardon, because I just thought that this is also something that should be equally important and should be covered. Okay, so there is no, nothing difficult in it. A balanced panel is when you have equal observation for each cross section, whereas an unbalanced panel is when you have unequal observation. For example, if I repeat that example of country A, B and C and these random variables, let's say if the value of per capita income for country A is missing for the year 2002, similarly trade openness index for country B for the year 2000, it is also missing. So now you can see that for each cell I don't have equal number of observations. So this is unbalanced panel. Okay. Next we discuss the concept of measurement of variables. Actually, if you explore the Introduction to Statistics playlist, or you recall the concept that you studied in the course of statistics, these are the concepts that you have already done, but this is sort of a, you can say, recap. So what is ratio scale? Actually, whatever data you have is supposed to be on a particular scale. For example, amount of money you have, it is something quantitative, right? And if I have zero money, that means I don't have any money, right? So the zero is meaningful. In other words, zero implies absence. Zero money means absence of money. Interval scale is again quantitative, but here 0 does not imply absence. For example, a temperature of 0 degree centigrade does not imply that there is no temperature. It's simply a particular level of, you can say a particular level of temperature that is given the value 0. It's not equivalent to saying that there is no temperature. Of course, that is going to be meaningless. So that is why in interval scale things are also quantitative, but 0 is meaningless. Next we have ordinal scale and nominal scale. They are more relevant to the qualitative variables. So ordinal scale, let's say, if I say on a scale of 1 to 5, how do you like the course of econometrics, right? Although apparently you will say that this is also a quantitative data, because we have values like 1, 2, 3, 4, 5. Or let's say even if I offer you on a scale of 0 to 5. So if you say that you choose 0, let's say, I repeat the question, I say on a scale of 0 to 5, how do you like econometrics? And let's say you choose 0. So what does that mean? It won't say that your tendency to like econometrics is absent. It's actually you can say dislike toward that course, that you have given it a 0 value. In other words, the whole debate of 0 versus any other value is meaningless in ordinal scale. So it's actually the data which has, let me redefine in a more easier way, the data on ordinal scale has a sense of naming as well as ranking. For example, the letter grades that the students get in a semester. For example, if I got an A grade, another student got a B grade. So not only our grades are different by name, they are also different in a sense that I know that A grade is better than B grade. So ordinal scale proposes naming along with a sense of ranking, whereas nominal scale, there is only sense of naming or identification, no ranking. A very easy example is our names. For example, if my name is Aisha Nazuk, that is just for the sake of naming. I mean, I can't say that Aisha Nazuk is a better name than, let's say, Sadia Khan. So our names are on nominal scale. So why am I telling you these details? As the course proceeds, you will see that whenever we have data on a variable, different techniques are applicable on it. If it is on ratio scale, or on, let's say, ordinal scale or nominal scale. In other words, if the scales are different, applicable statistical technique or the econometric techniques are different. Okay, so the much awaited slide of the lecture, as I appreciate the fact that, thank you by the way to all the audience and all of you, those who are watching the video, that you kept your cool actually to watch this entire lengthy lecture, and specifically for those I won't use the word weak, but relatively less better in statistics and probability, they may have found new things in today's lecture. So thank you for listening with patience. Now we have the last slide. Let's say you want to develop an economic model of criminal activity, and by the way, this is question 1.5 from Gujarati and Porter Econometrics book, 5th edition, which you can easily download from the internet or from the Genesis library. Okay, so question 1.5, I repeat the statement that you want to develop an economic model of criminal activities, and you want to see that, for example, how many hours people spend on criminal activities. What variables would you consider? although I have a list of variables already written here, but if you don't have a look at this list, you can just think, let's say you can do brainstorming, that in other words, what are the factors that indulges a person into criminal activities. Of course, there can be countless explanation. A psychologist will come up with an entirely different answer to this question. An economist will come up with a different answer, right? But so I have listed some of the motivations, or let's say some of the factors that can be related with explaining the time spent in criminal activities. So one of the factors is what are the wages or earnings in criminal activity. In other words, for example, if God forbid I start doing some criminal activity, so I will derive an idea that if I do this activity, what benefit will I get from it? That is, what amount of money will I get from this criminal activity? So earnings are important. Then I will also think that okay, if I can earn, let's say, $10 from this criminal activity, then is it possible that I can earn more than $10 in some other activity which is non-criminal? Then why would I take the risk of indulging myself into that criminal activity? So what wages I get in alternative non-criminal activities, that is also important. Then I will also think that if I exercise the basic human emotion, that is fear, I will think about the likelihood of getting caught, right? If I violate a traffic signal, for example, so I will have an idea in my mind whether that some traffic warden is there, some camera or speed monitoring, vehicle movement monitoring device is installed there. So whenever I indulge into a criminal activity, I will have an idea of what is the likelihood of getting caught, what is the likelihood of getting convicted by the court, and if I am convicted by the court, what is the expected punishment or the sentence that I will get on this criminal offense. So these are some of the variables. So as in take-home assignment, I just advise that you read some basic work of Gary Becker, the Nobel laureate, who gave so many contribution in economics of crime. So you can study some of his works and you can see whether these variables are they the one that Gary Becker also proposed, that these are the things that explain why people do crime. So here I end the lecture, and I thank you once again for listening with patience. I request you that if some part of the lecture was not clear, just try to watch the video again. You're also welcome to reach me out on my email address, or in the comment section you can give constructive feedback. So in the comment section I will post my email address as well. So if you want to reach me out through email, you can easily write an email to me. So best of luck, and let's meet you in the next video very soon.